works or whether the video is okay, because we have to be making like a video presentation soon. That's the board that I got from Propeller. Well, a lot of wires, of course, as you can see, it's all like ready made. All that I did was just solder these wires there and then added my little USB connector here so that I can connect it. And this is my pride. Yeah, I would say my pride because it is the board I built. Okay, this is an intro, so what I'll do afterwards is I'll break it down all and then show you exactly what goes in it. And the good thing about this is it takes 3 different power sources. Okay, now you can take power, tap it from the breadboard by connecting the wires, so it has 2 ends there, or you can use the USB, which is very good and handy. Or the third part is if you have 9 volts battery, you can use that, which is this one. Okay, basically you have your propeller chip. Don't mind about the PLM there, it's just my initials. I love doing that. And then you have the reset button here, which I've done, and then you have the 2 switches which are connected to pins 8 and 9 of the propeller. This is the power supply that gives me 3 sets of voltages. You have the 0 volts, which is the ground reference, of course. Now you have the 3.3 volts rail here, which is used to power the propeller and anything that needs 3.3 volts. Now on top of it here you have the 9, which is the 5 volts first, for devices that needs 5 volts, so you can use that. And then over here is where you get the 9 volts. That's the EEPROM. Actually I wanted to make connect another one there, 2 EEPROMs, so that the other one would be used purposely for saving data, and then the other one is the boot EEPROM. This bit here is just to show an LED output, like maybe you might just want to display something, okay, see whether something is working or stuff like that, so you just connect it here. And then over here is the programmer, the serial to USB converter, which you got from Propeller. And as you can see, it all goes inside, and that's it there. So all I would do is just connect it over there, and it starts reading it. So if I want to power it, that's a USB cable here, so I connect it here as well because I'm using it, and then see, the other end comes from there. So all that I would do is just plug it in here. Yep, let's do that. Come on. Yep, and we have it there. Then the next thing that's left to do is just to power it on. So when I do it, I have a light here that shows that there's power. There's a sample program that runs that will just be blinking these ones, and then it will be showing reading from the sensors that are connected. So far none of the sensors are connected. It's only the server that we have here, and then we also have the digital compress. Okay, so for the server, I'll just quickly run a test program, and then we see what the actual server does. Let me just switch over. Okay, we already have a test program there, so all I will do is just load it by pressing F10. So loads it, and then let's start it and see. It's a bit dim in here. Let's see if I can get some more light. So the server, oh sorry, my bad. The server is connected to another set of power supply, because normally you would separate the rails, so I didn't connect that bit, that's why. So let me just power that other supply for the server. The light goes on to show that there is 5 volts running there, and then there we have it. As you can see, it's turning. So this is just a sample program from the server that will show what we will be controlling. So basically what we will do is have our sensors have, let's say, the server, the 4 servers that we're controlling, which is for pitch, for banking as well, and then you have another one which is for the rotor, okay, for the to turn the aircraft. We're using a helicopter, by the way, and then we'll be using the servers to control it. So all that we will do is just, maybe if we find out that maybe it's going off course or it's pitching too much, you need to change the pitch up a bit, all right? So we will do that by through controlling the server. Now so far we've interfaced our compass. Later on we'll show you how that works, and then we've also interfaced our tri-axis accelerometer, which is so cool. And then you also have our guess what this is? Object detection, the infrared. See, transmitter and the receiver, both of them together. So this will go on the aircraft. Let's enable battery. That was the board I was using at first. It's just like connected my chip here, and then this is what I use to show my outputs, which is quite pretty normal. I didn't have any 7-segment LEDs, so I have to, create my own. But it was fun. It was fun doing it. This one came with a little bit of that, which is this one here. But this one I decided to put it on the board itself so that it's not outside. Okay, this is a brief intro on our project. So of course we will be recording much more of these ones, and then whenever we're done with one, definitely we will put it on so that everyone would see what we're doing. I really enthusiastic, so happy about this, but I just hope that it works. What we'll do afterwards, later on for the next one, we'll connect the server directly controlling the, let's say, the tri-axis. So we will then be moving the tri-axis up or down, that is pushing up or down, and see whether the server will respond. Okay, we will set it so that it would always center it, so the program would set it at 0, right, the axis. So whenever we turn, it will change to either positive or negative. It depends on how you configure it. Okay, now whenever it turns, the server should counter react that, assuming that it was level, the starting position. So when you turn down, that means that you are adding or subtracting, depending on how you configure it. The server should then turn the other way around to counter it. When you go up, it will then turn maybe anti-clockwise to counter it. If you go down, it then turns. So that's what we will be doing next. This is a brief intro. Afterwards we will show you the helicopter, how it looks like. Okay, meet you again soon. Hey.